In the last video in my 286 series, I had mentioned that I had done some updates to the PCB design, and the version that I've been using is this version here. It's a 0.10, and the changes I made were a 0.20. In my most recent videos on my VGA circuit, this is the 640 by 480 VGA circuit I'm working with. I've been using this version 10 or 0.10. And it's been working well, but I did get in the 0.20, and I thought I would go ahead and assemble that. So here's what I've been using. I'm going to take that off to the side now and show you the replacement. So this is now the replacement, and I'm going to go ahead and reset that screen. So this replacement, you're going to notice, is smaller overall space. It also has in the built-in reset functionality, so I don't need the separate card for that. And it has a built-in crystal, and right now I'm running a 16 megahertz crystal, which means 16 megahertz for the system and then 8 for the processor, but that's built right onto the board. So what you see right here is everything needed to run this specific system. And I thought I would just real quick talk through some of these changes so that if you are kind of tracking my changes as I go, this is what I'm going to be running probably for a while. And right now this board is running really well. I'm really happy with its performance, so I don't imagine ordering another PCB for a while until I can kind of queue up a whole bunch of changes. And right now I don't have enough changes that I'm looking to do. So if I walk through this, it's really the same things. I've compressed things together a bit. I've moved the SD card reader. I didn't bother putting in the Mega, the Arduino Mega I was using for lower speed debugging, because at this point I'm running high speed on everything. If I want to debug, I can put that in. I left room for it. This OLED screen is just replacing the smaller one I had. It's essentially the same thing. It's just a larger format. It's a 128 by 64, and that I can use for whatever I want to use for outputting on it. But I've been using it for post data. I'm not going to bother with this 8-character 7-segment display anymore. I'm just going to use one of these displays for that same data. And primarily because that display wasn't following all the rules for SPI quite right. So it was a little finicky in some spots because it wasn't following a chip select set of functionality that a true SPI, fully compliant SPI device would follow. So I'm just not going to use it. It was causing more problems than it was worth. My real-time clock just plugs right into a header now, and then I have things like my RAM up here. I added pull-up resistors for all the internal data and addresses. I still have the external pull-ups on the far right edge. You can't see them because they're underneath this set of cabling right now, but they're still over there. And then everything else is kind of over here. I did also swap to a different PPI, so these programmable peripheral interfaces. Basically, the versions I was using, you could not read back a register. So you can write the configure register, but you can't read it back. The versions I have in here, I believe I can read back the configuration register. So I'll get to this at a later point, but in my post-test code, I wanted to be able to write a config and read it back just to make sure it worked. And that was my indication that the chip was at least communicating and working okay. I should now be able to do that with these versions of these chips that I have. So I'll test that out. So again, I've got the crystal on board. I've got the reset circuit with the built-in watchdog. I just tied the watchdog to the peripheral clock on the system. So the system's really got to have problems before that watchdog is gonna do any good. Maybe later I'll tie it to like an address 0 line or something like that, so that if something stops working on the processor, this can auto reset the system. My post speaker is just sitting right here, the little header's there, and I just basically taped a little double-sided tape to the little amplifier IC that it's sitting on top of. I think the other notable change on this specific board is I doubled the size of my VCC and ground from the last board. So I was at about 0.5 millimeter for those traces. Now I'm at 1 millimeter for the VCC and ground. And then I filled the top with copper as much as I could, and that's VCC. I filled the bottom as much as I could, and that's with ground. And with all of those changes, this board is running great. And so that's really what I'm going to be running from this point forward. And if I didn't mention it, I decided to forego putting the Arduino in because that's really for lower speed debugging, which I really haven't been doing any of. Being that this display is mounted up a bit, I actually can still slide that Arduino in. I can take the display off temporarily and put in my headers and drop an Arduino Mega in, put the display back in real easily. And I didn't fill in any of these other headers. So anywhere you see unfilled headers, it's just because at the moment I don't have a need for them. But when I do need them, I can easily solder them in. I can disconnect a few things, flip it over, and get everything soldered in without too much problem at all. One of the problems I was having previously was getting power distributed. I could bring in power up here. This corner was fine. I could jump the power over to this board and I'd lose a little bit of voltage, but the breadboard was running fine. It was just this corner kind of struggled to get good power. And I thought maybe I could real quick do some measurements here. I'm going to go ahead and apply power to the system. And so it's going to go through, and right now for the post test, I'm doing 64K of the RAM just to test it out. I'm testing the VIA, I'm testing the math coprocessor, and then it's going through a PIC test, but it's not really doing that new configuration read back. So I'll get that updated to add that in. And then I'll be adding, if you've been watching my VGA series, I've got some tests that I'll go through and test the VGA and things like that. And at this point, I'm not recording the VGA output, but it's brought up my VGA screen also with this colored bar pattern test that I'm initializing with for now. But if I take a look at voltages, my power supply says that it's outputting 5.12 volts. And probably what I can do is just kind of see, what do I have for voltage, maybe up in this corner somewhere. And just so I don't maybe touch something the wrong way while it's running here, I'll just maybe read it right here at this IC. And at that IC, I've got 5.08. So I'm going from 5.12 to 5.08 there. And, if I want to go all the way up to the banana plugs here, I'm at 5.08, which is on the high side of 5.08. So 5.0888 is where it's at. So I'm losing, 0.03 to 0.04 between my power supply and the board. But if I say that, okay, at this point then, I am getting, let's just round it to 5.09. If I come down here and start measuring some chips, this one here, I got 5.07, and I'll grab my ROM, and I got 5.064. So I'm not losing much at all. So that voltage problem seems to be taken care of. And I did put some additional pin headers that I can go check those voltages anywhere. So here I've got 5.065. And again, going from 5.09 down to 5.06 and a half, I'm not losing really much there at all. So that's great. And then you can see coming from my benchtop power supply, I'm also plugging into a set of banana plugs. By the time it gets to this one, it's at 5.06. And actually that's not at the plugs, that's as it gets into this circuit. And if I go all the way down on my breadboard down here, probably to the worst case scenario would be this IC here. I'm at 5.046. So, really, power supply's kicking out 512, and my worst case scenario down here is 5.046, and maybe, if I'm saying right here 5.06 is almost identical, 5.0637. So from this corner or this corner, it's still all looking good. And if I was to grab something that's maybe more isolated in the middle of the board, 5.066, 5.06. So it looks like the worst is, the center of the board here, and that probably makes sense because a lot of this copper fill really stuck to the outside because there was so much here. So if I'm taking 512 in, I'm getting 506 here as worst case scenario on this entire thing. I am happy with that. And like I said, all my communication is working, all the SPI stuff is working. I haven't found anything that is not working at this point. And I'm really liking this form factor and how everything is just working well, nice and clean. So that's the board I'm going to use from this point forward. And the next thing I'm going to release is a real quick video. I do have the PCB done for this 640 by 480 VGA card, and I'll post that video maybe shortly after this one, just if you're curious on what that PCB is going to look like. And that hopefully will come in sometime in the next 2 to 3 weeks, and I can get this whole thing put into a single card in the system. So more to come on that. Thanks for watching.